During the lifetime of one of the most famous minds of the 20th century, Albert Einstein, the primary theory about the origin of the universe was the steady state theory, a theory that suggested the universe had no beginning, no end, a perpetual, unchanging existence. But then something unexpected happened. In 1927, a Jesuit priest, Georges Lemaitre, reviewed Einstein's general relativity equations. He realized something profound. It pointed to a singularity, which is a point where time and space as we know them converge. From this singularity, he theorized, the universe must have begun. Despite Lemaitre's bold vision, many renowned scientists, including at first Einstein himself, defended the steady state theory. In fact, Einstein had wedged a value into his equations called the cosmological constant that was really just a way to keep the universe from collapsing in on itself when doing the math. A problem the universe in rapid expansion after the Big Bang did not have to worry about. The steady state theory was championed by Sir Fred Hoyle, Thomas Gold, and Hermann Bondi, who argued that the universe was eternal and unchanging. According to their view, as the universe expanded, new matter was continuously created to maintain constant density, ensuring that the universe remained stable over time. In their model, there was no need for a beginning or an end, just an everlasting cosmos. They called this the perfect cosmological principle, arguing that the universe looked essentially the same at all times and from all places. It was a comforting theory, one that maintained the universe's stability and predictability. It was actually Hoyle who derisively called the opposing theory the Big Bang theory, and the name stuck. Both sides were at a stalemate, sure of their respective theories, sure the other side was misguided. Then along came Edwin Hubble. In 1929, Hubble provided the critical evidence needed to settle the debate. When something in the universe is moving towards you very fast, like speed of light fast, the observable light coming from it looks more blue. And if it's moving away from you very fast, the observable light coming from it looks more red. In fact, you can calculate how fast by measuring just how much it has shifted red or blue. By calculating the redshifts of the most distant galaxies he could see in his telescope, Hubble determined that the farthest galaxies were all moving away from our galaxy at speeds proportional to their distances. They were also all moving away from each other at speeds proportional to their distances. That means if you were to rewind time, all those points would end up in the same place. Through meticulous observation, Hubble eventually calculated the Hubble constant, a measure of the universe's expansion, and revealed something astonishing. Now, this constant has been refined significantly since its first discovery, but the principle still holds. All the galaxies we know of, and therefore all the matter we know of in the whole universe, started in one spot. The universe was not eternal and steady state. It had an origin. Hubble's discovery was a monumental shift in understanding. Data, evidence, proof. In the end, science is not a debate. The best orator may hold sway for a time, but science is about answering questions with as much clarity as we can, and that requires evidence. And yet, even in the wake of this discovery, some truths of the steady state theory endured. The steady state model had been right about the generation of heavy elements in the star's life cycle. Elements like carbon and iron, these elements that form the basis of the world as we know it, forged in the fiery hearts of stars. For Georges Lemaitre, the Big Bang theory hinted at something more. It pointed to the existence of God, the divine architect of creation. But even to many scientists of the time, the steady state theory had become like a religion. They were too attached to their view of the universe. And this is where true science shines. A good scientist does not argue for the sake of winning. They embrace the uncomfortable truth when new evidence comes to light, even if that evidence means that they were wrong. Science doesn't care about who's right. It only cares about what's true. Science is not a courtroom. It's a process, a journey, a quest for truth through evidence, not ideology. When new data comes forward, the argument is settled. We change our minds, we adapt, we grow. And that, perhaps, is a mindset we should all take to heart, in science and in life. Be willing to change your view in light of new evidence, even if it means letting go of old beliefs. If all you care about is being right, you may miss the very evidence that shows the truth.